Sir, good morning, sir. Hello.
Yes, good morning. How are you?
Yes, sir. Good morning, sir. How are you, sir?
Just waiting for my colleagues. So once they come, I think
Actually, one of
we can
your
start.
scholars have joined, sir. Pavement has joined.
Is she?
Both-
Okay.
Both of them joined.
Both of them have joined. Avishresh and Pavni. Oh, okay.
We'll start in 2 minutes, sir.
Sure, sure. Is Avishresh here too? I don't see him. Maybe. Avishresh also is there?
Pavement.
Avishresh? Yeah. Okay. Yeah. Okay, that's good.
Hello.
Yes.
Good morning, sir.
Morning.
Am I audible?
Yeah, you are. Thank you.
Thank you, sir.
Sir, can we start, sir? Hello.
Yeah, sure. We are ready. Yeah.
Very good morning to one and all. We welcome you once again to this day 5 session, the workshop on role of transportation engineers towards sustainable roads and traffic safety. And now I would like to request my faculty coordinator to introduce the speaker. Madam, please go ahead.
Yes, sir. Thank you, sir. A very good morning to one and all. I'm C.H. Pavni, working as Assistant Professor in the Department of Civil Engineering, Sri Vishnu Engineering College for Women. Would like to introduce today's speaker, Dr. Krishna Prapurna Garu, who is working as Associate Professor in the Department of Civil and Environmental Engineering at the Indian Institute of Technology, Tirupati, India. He obtained both doctoral and Master of Science degrees in Civil and Environmental Engineering from Arizona State University, United States of America. He holds a Bachelor of Engineering degree in Civil Engineering from Visvesvaraya Technological University, India. His research and teaching experience include transportation pavement materials, design, maintenance and rehabilitation, highway noise evolution and modeling, sustainable and smart infrastructures. During the last 16 plus years, he has been involved in several multi-million-dollar national and international studies that focused on fundamental materials, properties, and sustainable innovative solutions programs for adaptation initiatives. He is associated with various international societies such as the US-based National Academies of Engineering, American Society for Testing and Materials, and Recycle Asphalt Foundation, etc. He serves as Associate Editor of the Elsewhere's Resources, Conservation, and Recycling Journal, Associate Editor of the American Society of Civil Engineers, Journal of Materials in Civil Engineering, Associate Editor of the Taylor and Francis International Journal of Road Materials and Pavement Design, Editorial Board Member of the American Society for Testing and Materials, International Journal of Testing and Evaluation, Editorial Board Member of the Springer Nature's International Journal of Pavement Research and Technology. He is a lifetime member and executive fellow of the International Road Federation. He is also a recipient of the Young Scientist Award from the board of the International Institute of Noise Engineering. In 2015 and 2018, he was awarded the Asphalt Rubber Ambassadorship for the Republic of India, instituted by the Rubber Pavements Association, co-authored and contributed over 180 papers in scholastic journals and peer-reviewed international conferences and over 50 reports, press articles, newsletters, and guides till date. Further, he has also given many presentations in several countries, including India, USA, Sweden, Germany, Portugal, Poland, Belgium, Hungary, China, Singapore, Malaysia, Taiwan, United Arab Emirates, Australia, and South Korea. During the last several years, he has been advising, mentoring several scientists, undergraduate and graduate students, researchers, engineers, scientists, and practitioners. Sir, we welcome you to the session, sir. And I hope I hand over the session to Dr. Krishna Prapurna Garu. And I would like to I would like to welcome his scholars, Avishreshth Singh and Nagasiva Pamani Peraka. And thank you, sir.
There is small internet issues with Krishna Prapurna, sir. Sir will shortly join. I'll wait for a second. Yeah, thank you.
Yes.
Bhavani and Akshay, so welcome to this program. Sir, please go on, sir. Krishna Prapurna, sir. Yes, sir. Yes, sir.
Sorry, I actually lost my connection, but
Fine.
anyway, thank you very much once again, Girish, for inviting us and our group. So we have Avishreshth and Pavani, both of them are doctoral scholars at IIT Tirupati, and both of them have been with our group since 2017, December. And we are very happy that they are here. There are two aspects, as you can see, and it probably fits very well with the theme. One, sustainable roads. So as you know,
yourself. Hello.
I'm very sorry. I don't know what happened again. Sorry, Girish.
Yes,
Yeah.
sir, please.
So as you know, the theme of the session itself is sustainable roads and safety. So I thought we have very good speakers. Actually, both of them have done wonderful work in the last two and a half, 3 years. So one will speak about sustainable materials and roads aspect. The other one will speak on pavement asset management, which will also be linked with safety. So if you are able to detect the various distresses that are there on the roads, I think that will also help us build safer roads, which also will go back and then link itself with geometric design, right? So Girish, so I welcome both Avishresh and Pavani. So what we will do is we will have Avishresh talk about, go first, and then we'll have him talk about pervious concrete, on which he's been doing research, a lot of research. In fact, he has published more than about a dozen articles now, international journals and conferences. And Pavani also has done a lot of good work. She has done at least 6 publications in various international conferences and journals. So Avishresh, over to you. Please go ahead. Thank you very much.
Thank you very much, sir.
Good afternoon. Good afternoon, everyone. Am I audible?
Yeah, audible, sir. Perfect.
Yeah. First of all, I would like to thank the chairperson, the organizers, as well as Professor Krishna Prapurna for giving me an opportunity to speak on the topic of pervious concrete payments. This topic is very close to my heart. So without wasting much of the time, let's take a look at the contents of the presentation. Actually, this presentation has been divided into several aspects, where we'll first begin with a brief introduction to the material and its various applications. Now, once we have a brief understanding of the materials, the mixed proportions, various applications, then we'll actually discuss some field implementation research that we have done in the past 2 years. Once that is accomplished, we'll discuss about the environmental as well as the cost benefits of this material, as well as the associated payment systems. And at the end, we would like to conclude with some recommendations. So urbanization, as we all know, is basically a gradual shift of people from rural to urban areas. Now, the reasons we all know, there can be n number of reasons for this phenomena. One could be like better standard of living. Some others could be in the search of better job opportunities, better medical facilities. Now, as people are moving from rural to urban areas, there is a need for more infrastructure. It's because people need more housing spaces to survive, to live, and then they need more building spaces to work in the offices. So the most important part of an infrastructure that I would say here is the payment system, as it is the one which links the housing infrastructure with the office spaces. So payments in buildings, we all know, constitute the most of the impermeable fabric in urban cities. Now, based on some studies, it has been understood that payments, which are basically asphalt concrete and cement concrete, they constitute about 20 to 40% of the total impermeable areas of the impermeable fabric in urban areas. Now, as the impermeable fabric is increasing, what happens is, let's say we have a situation of an extreme rainfall event, then we often come across flash floods or runoff. Another problem with these impermeable systems is that during night hours, it has often been encountered that the temperature in urban areas is slightly higher. It's of the order of 2 to 12 degrees centigrades, I would say. It's slightly higher than the rural areas. So as a result, people often experience more heat during night times. This is basically because of the ability of these materials to store heat in their mass, which is released during the night hours. Now, such a phenomena is known as urban heat island effect. Now, the thing is, we know that these payment systems are an essential part of infrastructure. But then if you look at these impacts that they have, we need to come up with innovative materials or technologies, or I would say the payment systems that actually improve the quality of life and help in the creation of a sustainable urban habitat. So one such material and a payment system is pervious concrete. Pervious concrete is basically a mixture of cement, water, aggregates, and additive materials. Now, due to the absence of fine aggregates, this material has a characteristic interconnected pore structure, which allows the percolation of water through it. As you can see on the two images on the left side of my screen, on the top side, on the top half, you see there is a laboratory prepared pervious concrete specimen. Whereas at the bottom left corner, we have a field code pervious concrete specimen. American Concrete Institute recommends that for a concrete material to be designated as porous concrete, the minimum porosity should be 15%. The typical compressive strength of pervious concrete varies between 3 and 28 MPa, and flexural strength varies from 1 to 3 MPa. However, much higher values have also been reported in the laboratory. Now, moving on to the applications. This material is suitable for low to medium volume roads or parking lots or driveways. It is basically attributed to its low strength, which is due to the absence of fine aggregates from the matrix. Moving on to the materials and mixed proportions. Pervious concrete is basically mostly designed with the use of single-sized aggregates. The most common size ranges for pervious concrete vary somewhere between 19 and 4.75 mm. However, recently some researchers are trying to incorporate sand into the mixture, and their new range has been broadened somewhere close to 1.18 mm as well. Some other studies have further utilized fine sand of the true gradation, but the dosages at which it has been added is relatively small, most of them being restricting up to 10% by volume of by weight of coarse aggregates. The most common binding agent to create this pervious concrete material is ordinary Portland cement. Some other agents such as silica fume, fly ash, GGBFS may also be used. The whole idea of introducing those materials is to create a denser matrix as compared to the conventional PC, which would ultimately result in higher strength characteristics. The typical water cement ratio varies between 0.25 and 0.35 by mass. However, some people report it as high as 0.45. But based on laboratory investigations, we have found out that water cement ratio somewhere close to 0.3 along with a super plasticizer gives us best results in terms of strength as well as permeability. In case you want to have more details regarding the materials and the mixed proportions or some future work which could be done in this direction, you can go through one of our recent publications, which was basically a review paper published in Construction Building Materials. It discusses several facets of this material while also highlighting the existing research lacunae. Moving forward, let's discuss the construction of research test sections. Now, amongst the two test sections that we have constructed in Tirupati, the first one was constructed in the year March 2018 in Municipal Corporation of Tirupati. This was actually a part of smart city work. The test section that was created was about 4 meters wide and 125 meters long. The aggregate size, actually a binary aggregate gradation was used for the preparation of pervious concrete layer. By binary aggregate gradation, what I mean is that two aggregate sizes were used. One was 12.5 mm in lower sizes, and the other one was 6.5 mm in finer sizes. These two aggregates were blended with ordinary Portland cement in equal proportions to create a binary gradation. The cement to aggregate ratio was about 1:3.75, and the water to cement ratio was about 0.32. Further, a super plasticizer was used in order to enhance the workability of the mixture. The results of the study are also published in one of the international journals, Journal of Material and Civil Engineering, which you can refer to for further information. Now, in order to give you more insights on how this research test sections were constructed, I would like to show you a small video. Now, as you see, this was basically an initiative for Smart City Tirupati. First of all, the string lines were drawn and the subgrid was excavated and prepared with the help by passing about 10 to 12 passes of static steel wheel roller. Then granular sub-base material was laid and it was compacted again by about 6 to 8 passes of a static steel wheel roller. A formwork was erected towards one of the sides. This was basically a field laboratory that we constructed for research purposes. Alternate panels were constructed and the pervious concrete was compacted with the help of a vibratory plate compactor. The whole idea of constructing alternate panels was to make sure that the isolation joints were created without any deformations. Now, once the stretch was constructed, it was cured for about 7 days, and this was the final view of the test section. In these videos, here you can see like the water being poured onto the freshly constructed pervious concrete pavement, and you can see the rate at which it is percolating into the ground. Then again, as I discussed, a small formwork was erected towards one of the sides of the pavement. The whole intention of doing this was actually to compute the infiltration rate of pervious concrete pavements in the field. A lot of literature is available which discusses about the permeability rate of pervious concrete material in the laboratory. However, very limited literature exists which talks about the field infiltration rate of the pavement system, which includes both the surface as well as the sub-base layer. Now, this water that you see being percolating through the member, it's actually a real-time simulation. You can see the rate at which it is percolating. So in order to measure the infiltration rate, graduations were marked onto the formwork, as you can see, and the time taken by the water to fall from initial to final head was noted. Later, Darcy's law was applied to investigate the infiltration rate. Yeah, now moving forward, the first objective of the study was to construct the test sections, obviously, which was accomplished with huge success. Then the second aspect was to investigate the field infiltration of the pervious concrete pavement system, which included both the surface as well as the sub-base layer. So you see the Green-Amt equation as well as Darcy's equations were combined together, and it was found out that the infiltration rate of the entire system varied somewhere between 0.11 and 0.32 centimeters per second. Later, we did a surface infiltration rate test as per ASTM 1701, where about 40 locations on the entire stretch were selected and investigated. And it was observed that the surface infiltration rate varied somewhere from 0.02 to 1.28 centimeters per second. At the bottom of the screen, you can see there is an infiltration ring being sealed with glass putty over the surface of the pervious concrete pavement, and graduations were marked onto this ring. The whole intention was to maintain the head of water between 10 and 15 mm. And then the time taken by the water to, I mean, basically the idea is to note down the amount of water and the time it takes to pass through the surface of the pervious concrete layer. Based on this test, the PC layer, the pervious concrete layer, was actually segregated into several sections, which were designated as poor, fair, good to excellent, as can be seen on the bottom right side of the screen. Now, for the excellent test sections, where the permeability rate was higher than 0.5 centimeters per second, just for your information, I want you to know that some of these stretches gave us permeability values even as high as 1.3 centimeters per second, which is actually a very good number. Once these two tests were done, we tried to compute the infiltration rate of the subbase. Now, what we had was the infiltration rate through the system and the infiltration rate through the surface. The other task that was remaining was the computation of infiltration rate through the subbase layer. So in order to accomplish that, we actually utilized the layered permeability concept available in soil mechanics, and an equation was derived, as can be seen on the screen. And it was observed that the permeability rate of the subbase was somewhere between 0.07 and 0.11 centimeters per second, which is slightly lower as compared to the surface infiltration rate. But this may be attributed to the presence of fines, which was used to create a uniform platform for the construction of pervious concrete layer. The next study that I'm going to talk about was a test section which was constructed on campus IIT Tirupati. This section was about 5 meters wide and 50 meters long. You can again see the materials as well as the mixed proportion details are presented on this slide. The aggregate size varied between 12.5 and 4.75 mm, and the water cement ratio here was slightly lower as compared to the previous work, where it was reported as 0.32. In this case, it was about 0.3. Again, OPC cement was used, and the aggregate to cement ratio was 3.75:1. The results of the study have already been published in one of the international journals with ASTM, as Journal of Testing and Evaluation, which can be referred to for further information. So let's first talk about the construction chronology. We again excavated the existing substrate. A large amount of boulders, which are termed as excavated granulates, were removed from the site, because the presence of such large boulders actually will lead to the development of a poor substrate. So the first objective was to remove these granulates. Once that was done, good earth was laid, well compacted, which was followed by the laying of which was followed by the laying of aggregates, granular aggregates, in order to prepare the subbase. Further, the subbase layer was compacted with the help of static steel wheel roller. Then again, as you see, panels were formwork was erected, and pervious concrete surface was laid. The basic difference between this study and the previous one was that in the previous study, in situ preparation method was used. But in this case, ready mixed concrete trucks were used, where the concrete was first prepared at a batching plant, and then it came to the site and was poured through RMC trucks. So this actually increased the rate at which the pervious concrete was constructed. As you can see, the surface of the pervious concrete layer was compacted with the help of a vibratory roller. On the bottom left side of the screen, you might see there is a small blue colored sheet over which the vibrator rolls. This was basically done to prevent the sticking of aggregates to the bottom of the vibratory compactor, as such a phenomenon might lead to stripping or raveling situations in future. Now, again, one of the objectives of the study was to investigate the infiltration rate through the surface layer of pervious concrete, while recommending the optimum size of the specimen that could be prepared in the laboratory to come up with the field infiltration rate, or to replicate the field infiltration rate, I should say. So in order to do so, we had some CPVC and PVC slotted pipes of diameters and dimensions as shown to you. Then these pipes were actually embedded within the infiltration rings, which were made of high density polyethylene material. And as presented on the schematic on the right side, about 3 slabs were chosen where the infiltration rings were placed of varying diameters, starting from 110 mm to up to 630 mm. You can see this is how the infiltration rings were placed. They were actually sealed at the bottom with the geotextile materials. The objective was to seal the bottom so that water doesn't intrude into the lower layers. And the second aspect was to ensure that the aggregates from the lower layer as well as the top surface do not puncture. So once all of these infiltration rings were repaired, they were actually laid onto the test section. As you can see, the pipes were actually placed adjacent to the formwork, and fresh material was poured into it and compacted in a similar fashion as we do for the construction of the pervious concrete layer. As you can see, this is basically a infiltration ring which was placed over an embedded ring in order to investigate the infiltration rate of the system. On the right side, if you see, there is a small pipe which is projecting outwards from pervious concrete layer. So again, what we did here was we filled up this ring with a designated amount of water. In the meantime, we kept the outlet, the pipe outlet, closed, and once the initial head was noted, the outlet was open and the water was allowed to pass through the system. Again, the time taken by the water to fall from initial to final head was noted, and the Darcy's principle was used to investigate the infiltration rate. Now, amongst 3 test slabs, it was found out that one of the test slabs was clogged. So for final results, the readings of only 2 slabs were presented, and it was observed that the infiltration rate tended to decrease with the increasing size of the specimen, and the specimen and the ring diameter of about 300 mm actually gave us the true infiltration behavior of that of a full scale pervious concrete slab. Now, this 300 mm diameter that we observed, this is actually close to the ASTM infiltration rings diameter, which is also close to the 300 mm. This is a small comparative summary between the physical and mechanical characteristics for the 2 test sections, one at IITT and the other one at Municipal Corporation of Tirupati. So this blue bar actually presents the compressive strength, and the red bars present the average porosity. As can be clearly seen, for the test section that was constructed in Municipal Corporation of Tirupati, the compressive strength was of the order of 21 MPa. Whereas the one at Indian Institute of Technology, Tirupati, the compressive strength was on the lower side, only about 9 MPa. Now, as I told you, in the previous study, we used a binary aggregate gradation, where 2 different aggregate sizes were used in equal proportion. So based on laboratory tests as well as field investigations, we were able to corroborate that, okay, this binary gradation actually gives us the higher strength characteristics while maintaining the adequate porosity. As you can see, the porosity for Municipal Corporation test section was about 25%, which is much higher than 15%. Again, for IITT section, the porosity was really high, it was about 32%, but the strength was very low. Now, these are the schematics from a recent cyclonic event on which happened on 3rd December 2020. You can see on the left side there is an asphalt roadway, water being runoff being generated onto the surface of the pavement section. At the center, you can see there is an impermeable interlocking paver test section, where again water was ponded due to very high rainfall event. But on the right side, you see there is a pervious concrete parking lot. The entire campus, I tell you, was filled with water all across. But this was the only stretch where not a single drop of water actually accumulated over the surface. The entire water was drained into the underlying layers. Now, moving on to the environmental and cost benefits of pervious concrete. So in order to investigate the environmental benefits of this material, a small life cycle assessment was done. So the whole idea here was to actually develop a user-friendly toolkit which can be used for the computation of life cycle assessments by common engineers, practitioners with ease. So basically an Excel program was created, and the environmental impacts of the pervious concrete pavement was computed. This particular toolkit can also be used to compute the impacts of building materials as well as other types of pavement systems. So this was basically a comparative study where pervious concrete pavement was compared with that of Portland cement concrete pavements. The different steady parameters were embodied energy, carbon dioxide, kg CO2 equivalent, and capital cost. So a cradle to gate LC approach was adopted. By cradle to gate, I mean to say starting from the raw material production to the placement at the site. The results of the study are actually published in one of the journals whose details are shared below. So first the data was gathered, primary data which was directly collected from the construction agency, and secondary data which was actually collected from the existing literature. Again, this comparative study was based upon the test sections which were constructed in Municipal Corporation of Tirupati as well as Indian Institute of Technology, Tirupati. So you can see 4 different scenarios were compared: pervious concrete with a granular layer, where the mixing method was RMC, and versus the Portland cement concrete with a granular layer, where the mixing method was RMC. Again, for scenario C and D, the comparative assessment was same, with only difference being in the mixing method, that is the in situ. Then the functional unit was defined. Functional unit considered for the study was a 1 kilometer long road, which was 3 meters wide and 0.35 meters thickness. By functional unit, I mean to say that the aspect which was considered for the study to perform the study. So you can see there were different phases, starting from the material extraction to the mixing, transportation, as well as the compaction phases. The energy that was absorbed, that was consumed, and the emissions that were released during the entire process were quantified. So this is the model that was developed to compute these environmental impacts. These are again some of the equations which were used to define the input parameters within the proposed model. I wouldn't go into the much details of these models, as this can easily be looked at through the published version of the study. Now, this is where the comparative assessment comes into picture. As you can see, for RMC mixing, the embodied energy and carbon dioxide equivalents of pervious concrete pavement were lower than that of Portland cement concrete pavements by about 3%. Similarly, for in situ mixing as well, the embodied energy and carbon dioxide emissions for pervious concrete were lower than Portland cement concrete by 3%. Well, this reduction may basically be attributed to the lower amount of cement which was required for the development of the pervious concrete layer. Then a small sensitivity analysis was done to find out the parameter which was responsible for the emission of most amount of emissions as well as energy consumption. And it was found out that the material production phase actually results in the highest emissions as well as the energy consumption. Now, once the environmental benefits were quantified, the cost analysis was performed using the model which is shown on the screen right now. Again, it was observed that for RMC mixing, the cost of pervious concrete construction was higher than that of Portland cement concrete by about 1.2%. Whereas for in situ mixing, the capital cost was lower by about 4%. Now, moving on to the conclusions and recommendations, the first thing that we need to do is we need to establish laboratory as well as field correlations. A lot of lab research has been done in the past, but there exists limited field studies which actually corroborate the laboratory as well as field studies. Then we need to identify systems which have higher strength, but at the same time serve the purpose of water permeability. Then we need to construct pervious concrete pavements for all traffic as well as all weather roads. Then clogging is one of the serious concerns associated with pervious concrete. Pervious concrete has an open graded structure. So as a result, it often results in the accumulation of silt and dust within its matrix, which ultimately leads to the deterioration of the infiltration rate. Therefore, we need to come up with maintenance and repair strategies to enhance the life of this material. Then there is a need to develop a specified set of field implementation guidelines. Last but not the least, you need to further develop frameworks to quantify the benefit cost ratios, the environmental impacts, and the environmental impacts associated with this special payment material and the associated payments systems. Thank you.
Thank you, Mr. Abhishek, for your excellent session. Quickly, we'll see one question which is posted in the chat. I'll post a question. Can you go through the chat once? Then we'll hand over the session to Pavement.
Yeah, could you please? Yeah. Hello, yeah, Dr. Girish,
Yes,
you were saying something.
Yes, the question is posted in the chat. If please go through that and address the question.
Sir, you are not audible. Your voice sounds too feeble.
Could you see the chat box for the question that is posted in the chat? Hello. Hello.
Hello.
Could you able to see the chat?
Yeah, actually, I cannot right now.
Okay, fine.
Could you please say the question for my sake?
Yes, for sure. Somebody is asking about the clay soils, especially black cotton soils.
Yeah.
And lithomorphic soils, which has very less permeability values. In case if we find such type of soils, how well this pervious concretes will work?
Yeah, actually, see, there are some limitations associated with the construction of materials. In case we have a subgrade layer, which consists of fine sand, silts, or clays, then we should probably, then we have actually two options. The first option is we may not construct this material there because there are certain limitations associated with the subgrade, which might ultimately lead to the settlement of the payment system once open to traffic, as well as the other environmental conditions. But ideally, what we can do is that such studies are still on the laboratory scale. We have tried to do some work in this direction. And what we have come across is like in such type of subgrade conditions, we first need to remove about 500 to 600 mm of the native soil. And then that has to be filled with good gravel, good earth. And then maybe we can go ahead with the upper layers of the payment system. I hope that answers the question that was asked.
Yeah, thank you, Sis. Let us have the one more session. Then, if at all any queries on Pervious campus, we can address later. Okay.
Sure.
Yes, thank you very much for your presentation.
Thank you very much, sir.
I request the next caller, Pavani, please can you take over the session?
Thank you, sir. I'll start presenting now. Is my voice audible?
Perfect, ma'am.
Yeah, thank you. Good morning, everyone. First of all, I'd like to thank Dr. Girish for the introduction and inviting us to take part in this program. And I am Nagasava Pavani Perika, doctoral research scholar in the Department of Civil and Environmental Engineering, IIT Tirupati. So today I'll be giving presentation on the topic titled Advanced Toolkits in Pavement Asset Management Systems. And as we as a research team at IIT Tirupati developed analytical tools for enhancing data analysis pertinent to pavement asset management systems. So in today's lecture, I'll be briefly discussing about what pavement asset management system is and what are the modules of pavement asset management system, the pavement evaluation techniques, and what are the limitations of the existing pavement evaluation methods, and what the analytical tools that we have developed at the IIT Tirupati. So as we all know, the pavements deteriorate over time due to the application of repeated traffic loadings and variation in climatic and seasonal characteristics. And due to which the pavements needs maintenance. So if the pavements are not regularly maintained, then it will create discomfort to the road users and reduce the, so we need to payment has to be maintained so that the rate of repayment deterioration also gets reduced. So if the payment maintenance is not performed, payments deteriorate further and fail before their design life. So it is essential to perform timely pavement maintenance activities. So pavement asset management system assists decision makers and agencies to decide when and how to maintain payments within the allotted budget. As you can see on the screen, the curve in red color shows the change in pavement condition as the pavement ages. So just by observing the curve, we can say that the rate of deterioration will be less when the pavement is in its early age, and the rate of deterioration will drastically increases as the pavement further ages. So if we perform, so usually there will, the maintenance activities are divided into 4 categories. One is preventive maintenance treatment methods, corrective maintenance methods, minor rehabilitation, and major rehabilitation methods. The preventive maintenance operations will be performed when the pavement is in its early age. So, and the area under the pavement condition curve shows the serviceability of the pavement. So, if the preventive maintenance strategies have been performed, then the condition of the pavement will get improved and the serviceability will also get improved. And then if the preventive maintenance strategies were not performed, then the rate of deterioration will be more, and the pavement deteriorates further and it fails. So the agency has to identify which type of maintenance strategy should be performed so that the payments will last long. So for the development of any pavement asset management system for any agency, it should be abide by these objectives. The first objective is to collect the performance condition of all the road sections that are under their jurisdiction. Then from the performance data, it has to assess the condition of the pavement. After that, after assessing the condition, so the homogeneous sections pertinent to each road should be identified. Then how the performance, the pavement performance in the future has to be predicted. Then alternate maintenance strategies for each group of the homogeneous section should be identified. Then prioritize the road sections based on the need and based on the budget. After that, the maintenance have to be implemented on those road sections. So as I said, the first objective of PAMS is to collect the performance data of all the road sections. The performance data includes structural performance and functional performance. So usually structural performance data was collected by performing a structural condition survey. So for collecting structural condition data, so agencies usually go for non-destructive testing where falling weight deflectometer, bending beam diffractometer, or rolling weight diffractograph will be employed to collect the surface deflection when a peak load of 40 kilonewton was applied on it. So usually the bending beam, Benkelman beam deflectometer is a static load measuring surface deflection measuring device, which will not be useful for which will be disturbing the traffic for data collection. So therefore, later on FWD was developed, which is widely used in the world to collect the surface deflection data of highways. And the next thing is functional data collection. So in functional data collection, we need to one has to identify what is the roughness and what is the road comfort, ride comfort that it provides to the road users, and what are the distresses that are present on the road section. So the overall functional condition survey methods can be divided into automated and manual. In manual condition survey methods, an expert rater will walk along the road section and observe what are the distresses that are present on the road section and note them, and they will note down all the identified distresses into a rating sheet and assess the pavement condition by assigning some deduct values for each and every distress. And then in automated, since the manual data collection method is quite cumbersome, tedious and laborious, and the data collection for a stretch of 50 kilometers itself will take more than a week. So which will ultimately delay the data analysis as well, and the timely maintenance may not be applied for the payments which are in dire need of maintenance. So therefore, automated condition survey methods have been developed, in which a vehicle will be equipped with series of data collection modules. Those include cameras, laser sensors, GPS systems, and 3D ground penetrating radars and 3D data collection systems will be embedded to a vehicle, and this vehicle will be allowed to traverse on the road, and while it traverses on the road, it will be collecting the geometrics and the distresses data. This data will then be analyzed to assess the condition and to suggest maintenance strategy to the pavement. So here it's an automated road analyzer, which was developed by Fugro Private Limited, USA. And here these are the photographs of various automated data collection vehicles that have been in use across the world. So this is a schematic of a first generation automated condition data collection vehicle called Laser Road Surface Tester, developed by Swedish National Road and Transport Research Institute. And this is Pathrunner. This is Dynatest, which is mostly used in the USA. And this is Voters, which was developed by the researchers at Northeastern University, USA. And the Andhra Pradesh Road Development Corporation has initiated the road management system in 2016. As part of that, they have started collecting the functional condition data using a network survey vehicle, which was manufactured by Australian Road Research Board Limited, and it has several modules. As you can see over here, it has 3 cameras fixed to the front side, and then there will be one camera which is fixed at the back. So these 3 cameras will be capturing the right of way, driver side and the passenger side assets of the road. And then the camera which was fixed at the back rear end of the vehicle will be recording the pavement. The rate of collection is each frame is capable of collecting 10-meter long stretch and 3.5 meter, which can collect 1 lane width of road section. And this vehicle has been, we have requested the APRDC to send the vehicle to IIT Tirupati campus, and we have explored the vehicle, and we were given training on collecting the data using NSP. And this vehicle is capable of collecting the geometrics of the road section. Roughness will be measured by the series of laser sensors which were fixed to the front bumper of the vehicle, and there will be accelerometers. The readings of laser sensors and the accelerometers will be used to measure rutting and roughness as well as the texture. The cameras, the videos recorded by the cameras will be analyzed to measure the extents of cracking, pothole and patching. So the videos recorded by these vehicles will be analyzed frame by frame, and a person will be employed to measure to go through each frame of the video and quantify the extent of each distress based on its severity condition. And then that has to be noted down into a pavement assessment pavement condition assessment sheet, and a pavement rating will be assigned. So this is a very tedious process, and it will take days together to analyze the data. So therefore, automated data analysis techniques have been used, which include incorporation of image processing and machine learning techniques for analyzing, for detecting various distresses, superficial distresses from the pavement images. So afterwards, the recent developments in the computer vision. Computer vision made the researchers across the globe to make use of deep learning techniques for various applications. So the researchers who are working in the pavement management system field have also started using the DL techniques for detecting various superficial distresses such as cracking and pothole from the pavement images. So here are the few of the studies that are recently published studies in this field have been noted down. And as you can see, most of the studies had detected only one variety of distress from the pavement images. So what we thought was, why can't we detect more number of distresses, more different classes of distresses, such as cracking and pothole. In cracking also, there were several classes such as longitudinal cracking, transverse cracking, edge cracking, and alligator cracking. So we thought of developing a multi-objective, multi-distress detection system for detecting multiple distresses that are present in a pavement image using artificial neural networks, using artificial intelligence techniques. So in order to test whether our analogy is correct or not, we first developed the pothole detection and quantification system. So in which images of 41 images which had visible potholes were used, and then the images were pre-processed. The images were pre-processed, and then the image dataset was fed to a YOLO v3 architecture. YOLO is a you only look once a multi-object detection algorithm, which was widely used in traffic, like for detecting vehicles in traffic modeling. So this algorithm was customized to suit the detection of potholes in the pavement images. And then after detection, the area in which the pavement, the pothole was present, was segmented from the pavement image, and from that the amount of patching material required for filling the pothole or for doing the patching work was quantified. So the data set had 41 images of road sections in the Andhra Pradesh state, and the image resolution of each image is 1280 pixels by 960 pixels. And as you can see, this is the snippet of an original pavement image. Since if we the quality of data usually plays a vital role in the efficiency of the detection rate of the algorithms. So images were pre-processed using image processing techniques like histogram equalization, Gaussian filtering, and Gaussian noise removal techniques. After that, a label IMG tool was used to mark and label the distress types that are present in the pavement section. So here we considered 3 classes for potholes. So one is low severity pothole, medium severity pothole, and high severity pothole. So that we have taken the ASTM demarcation where they have classified the severity of potholes based on the depth. And then since the images are two-dimensional, we cannot measure the depth. So by visual observation, we have assigned whether the pothole is just by visual observation, by comparing the texture of the pothole with the background. So the depth was assumed, and an appropriate class label was assigned during the labeling process. After labeling, these images were then fed to the YOLO v3 architecture, and then and about 3000 iterations were performed. And at the end of the 3000 iterations, we have achieved a precision of 89.23%, and the network had identified the pothole regions, and a bounding box was marked on it, and along with the class label. So after that, a set of code was written in Python where the code will where the marked region will be segmented from the entire pavement image. And then as I said earlier, the camera facing the pavement is capable of collecting one width of the roadway section, which is about 3.5 meter. So I mean, one lane width of the road section, which is of about 3.5 meter. So the this pavement image, like the image resolution, was correlated with the pavement width, and the length was also been identified. From these dimensions, the segmented portion from these dimensions and the pixels of the segmented region, the patching area was approximated. And then the patching material, the quantity of patching material was found to be a factor, including the dry volume of the materials before compaction to the patch depth, patching area multiplied by the severity of the pothole. So which is nothing but the class level. Based on the class level, we would be able to identify what is the depth of the pothole. So by multiplying these three, we will be achieving the amount of patching material required to do the maintenance of the pothole. So these are the results, and this work has been published in Mayorpop 9 International Conference in 2020. So with the experience gained from the pothole detection system, so we used the similar YOLO version 4 and upgraded version of YOLO version 3 for detecting multiple distresses in the pavements. So we have totally identified six distresses which the system should detect in the pavement images as well as the videographs. So these distresses include alligator cracking, longitudinal cracking, transverse cracking, edge cracking, potholes, and patch deterioration. So for the development of the system, so we need to first prepare the data set. So for the preparation of the data set for training the system, we have collected some open source data which is available online. And then the data set, the images that are collected by the Andhra Pradesh Road Development Corporation as part of its annual maintenance program. So this is the framework that we have followed for developing the system. So first task is to collect and pre-process the data sets to suit the for the detection system. And then the existing YOLO v4 architecture was modified and customized to suit the multi-distress detection problem. After that, the images were fed to the network, and the network was trained and tested, validated, and tested on all the images, and the performance was reported. So here, this image, in this slide, I'll be talking about the data sets that we have collected and considered for developing the multi-distress detection system. So the first is dataset A was collected from Andhra Pradesh Road Development Corporation. So we have totally collected 1,308 videos of 541 road sections in the Andhra Pradesh state, and all these videos were segmented, and each video had about 500 video frames. So after segmenting these videos, we have written a MATLAB code for segmentation. And then after performing the segmentation, we have obtained 6,70,328 images. Since the data set is huge, we consider only 15% of the total images, which is 1,550 for this study. Out of those, after analyzing each and every image, then we found out 800 images which had visible distresses. So the images, each image has a resolution of 1280 by 960 pixels. Then the second data set is long-term pavement performance data set monitored by the Federal Highway Administration USA. So it's an open source open source data set where the images are made available for the researchers to perform various studies. So in this data set, the 1,758 images of asphalt road sections were collected. Out of these images, 400 images had visible distresses. So those 400 images were selected for this study, and each image has a resolution of 800 by 219 pixels. The third data set is called German Asphalt Pavement Distress Dataset, which is GAPS, which was the data collected by the German road research, road transport research.
Very sorry, Ma. Please go on.
Okay. German Road Research German Road Research Institute. So this data set has 2,468 images, out of which 318 images which have visible distresses were selected for this study. And each image in this data set has a resolution of 1920 by 1080 pixels. So since the data sets are coming from various different different geographical locations, these in some pre-processing steps were performed to enhance the image quality. Since the APRDC's data had videos, those, as I said, we have segmented the videos. After those, we have selected few images which had visible distresses, and then those were of RGB images. RGB is nothing but colored image. So then these colored images were converted to grayscale images. And then for dataset L, the dataset L images, as you can see here, the images that are taken in dataset L were 90 degrees exactly perpendicular to the direction of travel. So therefore, the images were first rotated by 90 degrees in anti-clockwise direction, and then these color images were converted to grayscale images. And then the dataset G already has grayscale images, so we have not performed any dataset specific preprocessing on it. After converting the images in each dataset to grayscale, a set of operations were performed to enhance the image quality. So those are histogram equalization and various filtering methods. So here this slide shows the variation, like how the original image and preprocessed images are. After preprocessing, the class labels, like we have to first teach the network where the distress is present and what type of distress is recorded in it. So for that, the 3 severity levels of each distress, like since we have considered 6 distresses with 3 severity levels, so a particular labeling was given to it. Let us say if the distress present over here is fatigue cracking of medium severity, then a class label of FCM will be assigned to it. So for the creation of annotations, we used label IMG tool. So in the label IMG tool, each image was read, and then a bounding box around the distress was marked, and then the particular class label was assigned to it. Then for the development of MDDS, we used YOLO v4 architecture. So YOLO v4 is an upgraded version of YOLO v3, where several data augmentation techniques were introduced to it in the backbone and head detection where these will be creating various number of will transform the input images and create a large data set so that the network performs better in detection. So then the YOLO v4 architecture was trained on MS COCO dataset, which has 60 classes, and then it had about 60,000. It was trained on about 60,000 images. So the learned network was then transferred and then these several files, configuration files related to YOLO V4 was modified to suit the multi-distress detection system, to perform multi-distress detection for this study. The number of classes in this study was 18. So the the classes were which were related to, which were mentioned in the YOLO V4 architecture and the weights file were modified to suit the 18 class detection problem, and the class data, like distress classes data, was also been updated into the system. And then the pre-processed images as well as the annotation files were stored into the system. For the training of this system, the entire 1500 images were split into training, validation, and testing sets. 65% of the total data set was used for training, 23% was used for validation, and 12% was used for testing the system. So since the transfer learning approach was adopted, so we used the pre-trained weights of YOLO V4 on MS COCO dataset first, and the network was trained for about 1000 iterations, so that the weights at each neuron will be updated to the actual problem that to detect for the MDDS. After 1000 iterations, the modified weights file was used for training the network again. So this, at the end of 7900 iterations, the MDDS achieved a precision of 87.44% and average loss of 1.5123, which was quite promising compared to the results that are reported in the literature. Then various images were tested on the MDDS, and the performance was recorded. So when the image, which is shown in the top left corner, was tested, the system had detected that the image has fatigue cracking with medium severity present in it. And then here this image was coming from dataset L. And when this image was tested on the system, it had detected that multiple transverse cracks of high severity were present. And then we also tried testing the system when RGB images were there. So we have tested several colored images, and then this is one of the colored images that we have tested. The system has correctly identified that medium severity fatigue cracking was present in this particular image. And then we have tested various images which had predominant shadows and where white markings were visible. So, but the system's performance was good. In addition to images, we have tested various video graphs as well. So for testing how MDDS, or how accurately MDDS detects the distresses present in it. So these are the videos, frames of 2 videos which recorded the road section between Kadapa and a road section in the Kadapa district. I did not remember the road section name. So after analyzing 32 videos, we have achieved a rate of an average rate of detection of 6.7 frames per second, which is quite good. In addition to the data sets, we have tested the MDDS performance by using various images downloaded from Google. So the orientation of the camera was different. As you can observe here, these two, the images. Observe these 2 images. The orientation of the camera was different from the one which we have used for training the system, and the image resolution was quite different from the ones that were used in the training of the system. So even though the camera orientation was different and the image resolution was different, the system has detected the distresses as LCM and LCH appropriately in this particular case. And this is a road section in Oregon, and it had the system had detected pothole with high severity, and then it had detected patching of medium severity over here. And then a video downloaded from YouTube was also been tested, and it had detected the patch deterioration with low severity in this particular field. In addition to all these merits, there were a few loopholes and few limitations of the study. So as you can observe here, the system has predicted the bounding box of the predicted distress was less than the actual extent of the distress. And here in this case, there were more than one distress present in it. Let us say here 3 distresses were present, but the system has detected only 1. And here in this case, the system has wrongly predicted a vehicle as a distress class. So these are the major distresses. These are the major mispredictions that we have found, and these predictions will be. These mispredictions could be reduced by training the system further by training it on multiple number of images. So these are the results, and this work has been published, is accepted for publication in TRR, Transportation Research Record. And as you can see, the developed system is the first study where multiple distresses, 6 types of distresses with 3 severity levels were studied and were detected using the system. And real-time detection is possible, and the mispredictions could be reduced by training the system on multiple images. And as you can see, the detection rate and the detection prediction probability will be high for the videos or the images that were taken by the camera which is facing the pavement. Thank you. If you have any questions, please.
Well, madam, thank you very much. I would like to extend thanks to both of you. And I must say, Mr. Avasist and Avasist Singh and Pavani have done excellent job, excellent work in your research. And maybe this assessment management is a new insight to us. So we request the participants to post your queries, or you can unmute and talk to these 2 people so that your queries will be clarified. Avashish and Pavani will let us wait for a while. Okay? So once we address the comment, then we can leave this. My voice is audible?
Yes, sir. Yes, sir. Yes.
So meanwhile, I'll ask Avashish, are you there?
Yes, I'm here.
Yeah, I have a small query. So
yeah,
normally
please.
You have done pretty good work in Pervious Concrete, very good number of journals that you have published. And a small query regarding concrete clog. So do you have any perceptions towards this, and how do you address? Suppose you are saying Pervious Concrete is giving a sustainable life, of course 20 to 30 years, we can see. But because of the concrete clog, there might be a chance to have a limitation towards service life. How do you address this problem?
Yeah, actually, see, one of the major limitations I would say with Pervious Concrete is its clogging behavior over a period of time. Now, I tell you, when we install Pervious Concrete systems, usually what happens is the particles which are closer to the diameter of the surface layer, they tend to accumulate within the voids of Pervious Concrete. Now, this is a prolonged process basically. What happens is, based on research and some investigations in the past, we have come to know that usually this clogging happens only in the top 10 to 25 mm layer thickness. Therefore, periodic maintenance using the conventional equipment, like you have conventional vacuum truck sweepers, okay, or sometimes, let's say in areas which are not subjected to very harsh conditions, even brooming is sufficient for the cleaning of these systems. But my recommendation is that every 2 to 3 months, you should have a vacuum truck sweeper running over the pavement surface, which will actually remove all the dirt and dust which is accumulated over the top layer of the Pervious Concrete system. Now, see, this system is highly tortuous in nature. So these fines, they usually do not go in the deep underlying layers. And I tell you, just like the subgrade, The biggest enemy of pervious concrete in the top surface is also clay. Right? So yeah, periodic maintenance is essential. Every 2 to 3 months, if they can clean with a vacuum truck sweeper, or I would say brooming along with some water sweeping every week is more than sufficient to take care of the system. Yeah, I hope I answered your question.
Yes. It is done.
Dr. Singh, this Dr. Vanskan Srinivas here. The point is, pervious pavements since many years have been known to only handle, low traffic volumes.
Yes.
Another point you just now, a few seconds back, you mentioned about the clogging of the pervious pavement, and you
Yes,
also
sir.
mentioned about the regular maintenance which is to happen, like vacuum sweeping. Now, the point is, first question is, how do you make pavements, pervious pavements, handle, a heavier load traffic? Number one. Number two, is it possible, because maintenance, vacuum sweeping, maybe once in a month or once in 2 weeks or once in 2 months would be, there would be some maintenance cost. So maintenance cost vis-a-vis the construction, how do you assess it? There's a second question. Thank you. I need your attention on this. Thank you.
Thank you for your question. Actually, see, in terms of maintenance cost, if I tell you, I tried to do some, a small preliminary analysis, I would say. So based on that, what I could find out was, if you talk in terms of life cycle cost, then the maintenance requirements, actually the life cycle cost, which includes all the placement, the production, the placement, the maintenance, and the end of life costs. For pervious concrete, it actually came out to be lower, because see, the advantage here is we are basically using the similar equipment which is used for the cleaning of conventional roadways. That is the first thing. Second thing is the other distresses in pervious concrete, such as severe cracking, severe raveling, do not usually happen until unless they are subjected to the loads which are higher than the design strength, or the design number of repetitions, I should say. If the loads are if the repetitions are much higher than what it was designed for, then yes, such cases are bound to happen, and it is a challenge that we need to address. But yeah, based on the preliminary investigations, I could say, and as well as there are some supporting literature which clearly demarcates that pervious concrete is actually a cheaper alternative. Now, another thing is, see, in India, we do not usually practice this, but when we construct a pavement, or let's say a parking lot also, for example, we often create a stormwater management system underneath, which again is a very costly system. But for pervious concrete, we do not have to create such stormwater systems to mitigate the runoff problems. So again, this material comes out to be cheaper in the life cycle terms. Now, the second question is regarding the strength. Actually, this pervious concrete section, which was constructed in Municipal Corporation of Tirupati, the average strength that we could attain was somewhere close to 25 MPa. Now, we have also been trying to develop some high strength pervious concrete mixtures, and actually we are almost on the verge of finishing up that task. So I don't have the permission to divulge a lot of details in that regard right now, but I can assure you that we have been successful in creating pervious concrete systems which will have a strength of the order of 40 MPas. The results of these studies will be available soon online.
Yes, that addresses my questions adequately. One last question is, you've been talking about pervious concrete. Now, how do we compare pervious concrete, the pavement's performance, vis-a-vis the pervious bituminous pavement?
Porous asphalt, you mean to say?
Absolutely, porous asphalt.
Yeah, see, the problem with porous asphalt is rutting. Rutting is the enemy, the temperature, I would say. In pervious concrete, this temperature is not really a problem, because we know for concrete members, such deformations, such delaminations doesn't usually occur due to temperature effects. But in porous asphalt, we have often seen similar to the conventional asphalt pavements, this rutting is a phenomena which might occur over a period of time. And another problem is that once the rutting begins in porous asphalt, it also initiates raveling because the matrix is not dense. It is basically open graded in nature. However, in porous concrete, I would say the major distress is only raveling. And that too, based on my experience, I can tell you, it purely depends on how the pavement was constructed during its initial phases of life. The test section that we constructed at IIT Tirupati, there are some of the sections which have raveled out. Now, this is because we understood that there were some limitations during the point of construction. We obviously don't have skilled labor in our country. So we had to encounter some problems before the labor could also get a feel of what they were doing. So yes, there are a few sections, few slabs, which I would say have raveled out. But at the same time, when I talk about Municipal Corporation of Tirupati, where I would say the construction was much more efficient, I tell you, there are municipal utility vehicles, trucks, JCBs, which have been running onto the test section. And not even a single aggregate has actually reveled out for the past 3 years.
Sounds good. Thank you.
Yeah, thanks a lot. Thanks a lot for your questions. Any other questions, please?
Yeah, there is one. Someone is asking to explain how it will affect the groundwater table.
If I tell you very honestly, I don't have numbers where I can tell you the exact quantification. Okay, like this is the benefit. But yes, I can only tell you based on literature that since this system allows the percolation of water into the natural ground, so yes, there is significant benefits in terms of rise of groundwater table. This payment system can be much beneficial for construction in areas which have a poor groundwater table and often face high or very low rainfalls. In case of high rainfall, again, we have an option to store that water. In case of a low rainfall, we have the option of allowing that water to infiltrate into the ground, which will maintain the discharge in the underground aquifers, I would say. Yeah.
What are the main failure modes occurring due to blending and segregation of materials in highway?
Sorry. Yeah,
what are the main failure modes occurring due to blending and segregation of materials in highway pavements?
What are the main failure modes occurring?
Yeah, because of the bleeding and segregation of materials.
Actually, bleeding and segregation, all these bleeding and segregation, yeah, it happens in pervious concrete also, I tell you. And the basic failure mode because of this bleeding or segregation is the hampering of the infiltration capacity. Yeah, we have seen across, like there are some occasions when the water content is not monitored properly during the construction. So what happens is, I can share the pictures for more details in this regard if people want through emails as well. What we have observed is that the cement paste has actually come out and up to the surface of the material. And that actually leads to zero infiltration, I would say. The water starts to just run as it runs over a conventional pavement. Then again, another scenario is if during the compaction, again, if the moisture contents are not properly maintained and if the vibratory effort is too high, see, there is also a particular window for vibratory compaction. If we exceed that window, what happens is the paste tends to drain down at the bottom. That has also been encountered in field as well as laboratory studies. And once the paste goes at the bottom, it creates artificial clogging right at the stage of construction itself. So again, the water doesn't infiltrate into the ground. Just remember, the basic objective of constructing pervious concrete is to ensure the infiltration of water into the ground. And yes, these are some of the challenges which you might encounter if you do not compact, if either you do not compact the pavement properly in the desired time window, or if the moisture contents are not as per the prescribed limits.
Thank you, Space. And I'm very happy that this work is done by the in Tirupati, and the Municipal Corporation Tirupati is doing this and having pervious concrete roads some places. Because I belong to Tirupati, because I stayed in Tirupati for 4 years during my graduation way back in 2008.
Wonderful, wonderful. It's really good to hear from you.
The Tirupati is a very good place to enjoy. I mean,
Right,
it's a cool place. Yes.
Yeah.
Probably you might be experiencing now for the past few years.
Yeah, I have experienced.
Okay, fine. Thank you. That's all for the queries regarding Pervious complete. And coming to the payment assessment.
Thank you very much for your
thank
time
you.
and the
Yes,
questions
thank
that were posted from the audience.
Yes, it was a phenomenal work that you carried out. Thank you. Wish you good luck on the stage.
Thank you, thank you.
Yeah. And coming to the payment assessment, a small query, madam. So we have done various techniques for the assessment of payment condition assessment. Could you just name out what are the problems that you encountered while solving this? You are using some algorithm or software to do this payment condition assessment, and then therefore you have solved it and got the good result. Hello?
Yes, sir.
My question is clear to you because this payment condition assessment is quite interesting. Maybe I can suggest my students to work on. So maybe if you can give some insights about the problems that you encountered in solving those problems using different techniques, maybe it might be giving some good insights to the students.
Yes, sir. Your question is clear to me. The major problem that I faced is identifying the basic architecture which has to be selected for distress detection. So the since artificial intelligence area is booming now, so there are several new techniques have been coming up every day by day. So we need to identify the ones which had performed really well, and we should be in constant touch with the literature, and we should be focusing which has the highest performance in terms of detecting real-time like object detection in real time, and find out that algorithm and what is the how the architecture can be transformed so that object detection in payment systems could be used. In my case, first I have planned to take convolutional neural networks, but it did not work. But it cannot be used for detecting multiple objects. So therefore, then I moved on to VGG network, so which has very less real-time detection. Then I came across this YOLO version, which is performing really well in real-time detection. So that architecture I chose for multi-distress detection system. So, and we need high performing computers with high performing capabilities. So because the for running the entire data set, for running 1000 images at a time, it took about 15 to 20 minutes on a computer which has 38 GB RAM. So we need high performance computer for taking up such kind of jobs.
We have a vast number of evaluation techniques for payment condition assessment. With your experience, hello, my voice is audible. Hello, madam.
Sir, your voice is actually breaking a little bit.
Maybe because of internet issues. Okay, well, yeah, we have a good number of evaluation techniques towards this payment condition assessment. Could you just name out any fastest, fastest technique out of the available techniques to give the payment assessment condition?
Sir, I would say there were a few techniques where they have through the literature. So there was a study where conducted by Gopalakrishnan. He is from Virginia Tech University, Virginia State University, I guess. They have developed a cracking detection system using VGG16 network, which has reported very good precision rate compared to any other study conducted in that in the decade. So that was a good technique, and then because they used the basic architecture of VGG16, and then they customized it so that the cracking could be identified in the pavement images. And then there is another study conducted by Ukwa. They have used YOLO, the one which I have used now. So they used the version 3 of YOLO and identified potholes in the pavement images, and they have used more than 40,000 images for training the network. So their accuracy was close to 88%. So that could be also used for pothole detection. And the one which we have done was new. because no, in the literature, no one has reported a multi-distress detection system, but we have considered detection of multiple distresses for varieties of cracking and potholes and patching. So I think ours is good enough to detect more number of distresses from the pavement measures.
Ms.
Thank you very
Pavani, with the permission of Dr. Girish,
Yes, sir. Please go on, sir.
I wish to ask a question to you, Ms. Pavani.
Yes, please go on, sir.
Now, with reference to the query asked by Dr. Girish,
Sir.
Ms. Pavani, you were mentioning about the data set which is to be used to train a certain network. Now, the point is how many images you need to store it in the database, to how many images you have to store in the database I have, let's say I have a test case. There's a test case for which I have to do a surface evaluation. I have to do a surface evaluation. Okay, now
Yes.
I wish to, I'll capture the image of the current surface condition of a pavement, and I want to assess it.
Okay.
Now, in the database, how many images I need to store on an average to ensure that I get a reasonable accuracy? How to define reasonable accuracy? Around 90%.
Yes, sir. It should be around 90%.
So, how many images you think they should be stored in the database?
Sir, if we go through the computer science journals where they reported the performance of the architectures, they have used millions of images. They have tested the networks on millions of images and reported the performance. So we will be using such kind of architectures which has performed really well on the data sets which had millions of images, and we will be customizing it so that pavement detection could be performed using those architectures. So in our study, so it is always recommended to go to select more than 1,000 images. So there is no hard and fast rule that these many number of images should be used. So the minimum number is not reported anywhere in the literature, sir. So we have to get as many number of images as practical, and using image processing techniques such as changing the contrast of the existing image, we can increase the brightness and increase the contrast, reduce the brightness, reduce the contrast. Like that, we can create multiple number of images from the data that you have collected. Let us say I have a road section between Bhimavaram and another location. So I have collected about 100 images from the of that road. So what I have to do is that 100 images may not be sufficient to get highest accuracy. So then what has to be done is we have to make use of several image processing techniques, like adding some noise to the image, such as either salt and pepper noise or Gaussian noise, and which means by adding such kind of noise, you will be getting a new image, and which will be added to the data set that can be used for training the network. So there is, we cannot directly say these many minimum number of images are required, sir. So the network may give you a better accuracy for the images that you have used for training it. But when you test an image which is coming from outside, which comes from the other data sets, or which you when you try testing the system's performance on images of other road sections, then the accuracy will be very low. So we have to make sure that the data sets are, the data set includes more number of variety of images and more classes, like equal number of classes, the images with equal number of object classes were defined to it, so that we can avoid the class imbalance issue, and as well as the overfitting.
But then I read somewhere that noise is something which has to be actually removed from an image to make it's kind of cleaning process. Now
Yes.
you're saying that we need to introduce some noise. I mean, it didn't sink into my mind.
Okay, sir. Sir, actually what happens is, why I introduced noise removal is because I did not perform, I did not enhance my data set by adding the noise. What I have done was I removed the noise from the images. and then I tested it. But there are several other techniques where you will be introducing noise to the image and then select the region where the distress was present and use it as an image for your data set. So this is one of the techniques where you will be increasing the data set. When we have a limited data set, so adding a noise will create another image, and that will be added to your data set so that the number of images that you have for training the network will be more.
How difficult or easy is to acquire or get data sets?
Sir, collecting, like if you need a proper data set, we have to get it from the agencies, but we need to because they will be conducting the functional distress surveys every year. So it is recommended to get the data sets from the agencies. Let us say in the case of Andhra Pradesh, it is recommended to get it from the Andhra Pradesh Road Development Corporation. But if you have, like, there are other data collection methods are also there. So you can just take a cell phone, fix it to a vehicle, collect the data, like create a video when the vehicle traverses on the road, and get the video and segment it frame by frame, so that the video data collection rate will be ranging from 10 frames per second to 50 frames per second. So if you record a video of about 1 minute, you can get about 100 frames, 60 frames, not 60, 600 frames. So like that, you can also collect the data by yourself, but the most appropriate data that you can trust will be with the agency. So, but and there are some open source data sets are also there. So, as I mentioned in my presentation, the LTPP, the
long-term payment performance.
Yes,
long-term payment performance.
Yes, sir. Yes, long-term payment performance. If you go to the website, you can actually see the images of several road sections in the USA. So you can directly download those images. Those are downloadable. You don't have to give any credentials to it. Just you can download it. But when it comes to the German like asphalt payment distress data set, we have to send one consent letter to the researchers. Then they'll give us the permission to download the data set. So it's a trickier process to get the download from the German roads.
Thank you. Very well, nicely explained. Thank you. Good day.
Thank you, sir. Thank you.
Sir. Yeah, Bhavani and Stage, thank you very much. Well, let us close the session, and thank you once again for coming and joining us and giving your experience and sharing your knowledge and research work. I wish you good luck for your PhD. Thank you very much.
Thank you so much, sir. Thank you. Thank you so much.
Thank you.
Dear participants, please provide your feedback in the link provided in the chat box. And in the afternoon, the session would be started by 3 o'clock. So please join by 2:50 p.m. And the session would be addressed by Dr. Pala Girish Kumar. Please join the session by 2:50 p.m.
Madam, hello. Answer. I'll just check my voice. Hello.
Sir?
Check my voice because afternoon I have a session, but so many are telling me my voice is not audible.
Okay,
Is
sir.
is it clear and manageable?
Yes, sir. It is clear, sir.
Okay. There is no breakage, no? If I talk like this?
No, sir. No breakage, sir.
This is fine.
Okay, sir. Fine, sir. This is fine, sir.
Okay, thank you.
Sir, we'll just sort out this in the afternoon session, sir. Dear participants, those who gave feedback, you can leave the session, and afternoon session would be at 3 p.m. and please kindly join the session by 2:50 p.m. And we'll sort out the internet issue. Please join by 2:50 p.m.